We've all heard about Elon Musk's SpaceX, Jeff Bezos's Blue Origin, or Richard Branson's Virgin Galactic, but what do they actually do? Well, in simple terms, these companies are looking to get us into space more often by making going up there easier, faster, and cheaper. So how exactly are they planning to achieve this? By coming up with new ways of getting out of Earth's atmosphere, which has been essentially unchanged since the days of NASA's Mercury program more than half a century ago. Now, we're not talking about the usual suspects, like chemical rockets, nuclear thermal rockets, nuclear electric rockets, or even solar sails, though these do all have their own advantages and disadvantages. Instead, we'll be looking at some more out there ideas that could one day make interplanetary travel a reality. First, let's have a look at what these new propulsion systems would need to achieve. Well, for starters, they'd need to produce large amounts of thrust. After all, overcoming Earth's gravitational pull is no easy feat. For comparison, NASA's Space Launch System, the most powerful rocket ever built, produces around 8.8 million pounds force of thrust. Second, they need to be efficient. We can't just build bigger and bigger rockets to go further and further. We need a way to travel to other planets that isn't constrained by the laws of physics. Third, they need to be reusable. While current rockets aren't exactly designed to be flown multiple times, it makes sense to recover the booster stage for more cost-effective launches. Ideally, we'd like these new propulsion systems to be able to land back on Earth without damaging anything important. And finally, ideally, they'd need to be very safe, because we don't want to end up causing any damage to the Earth or other planets. So now that we know what we're looking for, let's take a look at some possible options. First up is an ion thruster. This type of engine uses electricity to accelerate ions to create thrust. Now, while this might sound familiar, ion thrusters work in a slightly different way to conventional electric cars. In an electric car, electricity is used to power a motor, which then powers the wheels. In an ion thruster, electricity is used to accelerate ions, which are atoms that have lost some of their electrons. When these ions are accelerated, they create a small amount of thrust. Ion thrusters are already being used in space today, such as on NASA's Dawn spacecraft, which used an ion thruster to orbit both Ceres and Vesta. However, ion thrusters aren't very powerful, so they wouldn't be suitable for launching spacecraft from Earth. They are, however, very fuel efficient. This means that they could potentially be used for long-duration missions where fuel is scarce. Next up is a solar sail. A solar sail is basically a giant mirror that uses the pressure of sunlight to create thrust. Now, you might be thinking, surely that won't work. The sun doesn't emit any light, so how can we use its pressure? Well, the answer lies in a little-known fact about our universe. Everything is made of light. Even the sun is made of light. When the sun shines, it's emitting photons, which are tiny packets of light energy. These photons travel at the speed of light and exert a small amount of pressure on anything they hit. Solar sails are coated with a thin layer of metal which reflects the sunlight, creating a small amount of thrust. Now, this might not sound like much, but over time, this can add up to a lot. For example, in 2012, the Japanese spacecraft Icaros used a solar sail to travel to Venus and reach speeds of over 37 miles per second. That's fast. But again, this isn't enough thrust to launch a spacecraft from Earth's surface. However, solar sails could potentially be used in conjunction with other propulsion systems to provide additional thrust during a mission. Next up, we have a concept known as a solar concentrator, which aims to use mirrors to focus sunlight onto a small area, heating a propellant such as hydrogen to incredible temperatures and allowing it to be released as a high-speed gas. This can then be used to create thrust. The great thing about this is that it doesn't require any fuel at all, just good old-fashioned sunshine. However, the problem with this is that it requires huge mirrors and lenses to focus the sunlight, making the overall system quite bulky. It also requires a lot of moving parts, which reduces reliability. Moving on, we have another option called a mass driver. This is a proposed method of transportation that would use electromagnetic fields to levitate and accelerate a vehicle without any physical contact. Essentially, this means that the vehicle would be suspended above the surface of the planet and accelerated by electromagnetic fields. The benefits of this are that it would be incredibly efficient and could potentially reach very high speeds. However, the drawbacks are that it would be very expensive to build and operate, and it would be difficult to stop the vehicle once it's in motion. Next, let's talk about something called a railgun. This is a type of electromagnetic launcher that uses two parallel rails to guide a projectile along a set of tracks. By passing a current through the projectile and the rails, a magnetic field is created which propels the projectile forward. Railguns are already being tested by the US Navy as a possible replacement for traditional naval cannons. However, they have the potential to be used for space travel as well. The main advantage of a railgun is that it can accelerate a vehicle very quickly. This means that it could potentially reduce the amount of time it takes to reach orbital velocity, thereby reducing the amount of fuel needed. However, the downside is that it requires a lot of energy to operate. Next, let's look at the laser propulsion system. Now, this works by using powerful lasers to heat a thin layer of material on the surface of a spacecraft, creating a plasma that can be used for propulsion. This can either push the spacecraft forward or slow it down as it approaches a planet. The biggest advantage of this method is that it's very efficient. In theory, 100% of the energy in the laser can be transferred to the spacecraft, whereas with chemical rockets, only around 10% of the energy is used for propulsion. The rest is wasted as heat and light. However, the major drawback is that it requires very powerful lasers to create enough thrust. Last, but not least, let's discuss a concept called a warp drive. Now, you might be thinking, surely this is just science fiction. But hear me out. A warp drive is basically a spacecraft that can manipulate space-time to travel faster than light. Now, this might sound impossible, but according to Einstein's theory of general relativity, it's not. In fact, if you could find a way to create a warp bubble, you could travel faster than light without breaking the laws of physics. The biggest advantage of this is that it would allow us to travel to distant stars and planets in a matter of seconds. However, the drawbacks are that it's probably impossible, and we haven't even begun to figure out how to make it possible. Okay, so those were some interesting options for the future of space travel. Now, let's see how they stack up against each other. Clearly, the best option is whatever Elon Musk and his team at SpaceX are cooking up. Just kidding. But seriously, they have managed to revolutionize space travel with their reusable rockets. Their Falcon 9 boosters are now routinely recovered after launching satellites and other payloads into orbit. And the company is on track to launch its first crewed Starship rocket later this year. If all goes well, Starships will be able to carry people and cargo to the Moon, Mars, and beyond. So while none of these technologies are yet ready for prime time, who knows what the future may hold? Maybe one day soon, we'll all be zooming around the galaxy in warp speed. Okay, so maybe that last one isn't so likely. But the point is that these kinds of new propulsion systems could one day change the way we travel to space. So who knows? Maybe one day, we'll all be jetting off to the stars in style. Anyway, I hope you enjoyed this video. If you did, please don't forget to leave a like and subscribe. Thanks for watching, and I'll see you in the next one.